I think I'm looking at lesson set 20, which is a test. I'm going to do problems 1 through 29 and then finish problems 30 through, what was it? I think 57, 30 through 57 I'll do later in the day. These first 20, 30 problems are pretty darn repetitive. Been doing the other lesson sets, so if you want to get better explanations or more detailed explanations, probably in the first 5 or 6 lesson sets, I talk a little bit more about those initial problems. At this stage of the game, if you've been doing those other lesson sets, then as Yasser would say, peasy easy, I hope, except when I'm talking to you, I make careless errors. So let's hope I don't make too many, but we'll catch them. I got folks who will write and correct, which is great. All right, so here's I'm going to do 3 problems per whiteboard slab and go around the room. So linear function, I see -2, 3. I immediately write x plus 2 plus 3. I look at the change, the linear change, which is to the first power. 3 to -4 is down 7, and -2 to 12 is up 14. And I don't care if you leave it like that. You can certainly write -1/2. Slope-intercept form. So I'm going to distribute -3/5 x. That will not be part of the grading. I expect everybody to get that without any difficulty. A minus times a minus is a plus. So we got 3/5. And then we got -7, which we'll write as -35/5. And so final answer, -3/5 x. 3 minus 35 minus 32/5. All right, so we're looking at 3 coordinates. Let's get rid of that. 3 coordinates. I like to do the x column first. I'll start with 1. I'll change by 5. Change by 5 again. I'll start with -7. I'll go down 3, -10, -13. I'll check to make sure there's no careless error. 11 minus 1 is 10. That's nice. That's a multiple of 5. 2 times -3 is exactly what I just did. Okay, I got a subtraction in standard form, which means this function is increasing. Let's hope I don't make a mistake. So I think I wanted the x and y intercepts is what was on the test. So we've been talking about doing that immediately for standard form. So the y becomes -11/7. And the x becomes 11/23. That's near a half. Near the origin, that one is a little bit bigger, further away, and there's my increasing function. All right, if I want to solve this problem, I think the best bet is to bring an eraser, which I didn't do, of course. One of these days, yeah, you would think after 20 lesson sets, I would have enough memory to get equipped properly. Get that out of the way. Okay, let's multiply by 8. 4 goes at 8 twice. That becomes -6x. That becomes -40. And the 8 cancels. -5x. I'll bring the 6x that way. So therefore, that becomes x equals -40. System of equation. Let's solve for the point of intersection. I have 2 functions that are increasing. This one is increasing at, put the -2 under the 3, change the sign, and that one's going up at 3 to 2. And it's starting at y-intercept of -7/2 -3.5. Up 3 to 2 looks something like that. This one, the y-intercept is -6, excuse me, which is here. And then that's a -1. So 2 over -1, change the sign. That's going up 2 to 1, a little quicker. So I'm getting an x value that is pretty small, but positive. Let's see if we can find it. Let's solve for x by multiplying this one by -2. So I have 3x minus 2y equals 7. Really easy to make mistakes here because it's such a tedious problem. I've got -4x plus 2y. And if you could keep doing this, you wouldn't even write that column. -12. Looks like I have -x equals -5. Looks like x equals 5. Okay, that's a little further to the right than I thought, but yeah, it makes sense. And if I put 5 in, 15, y becomes 4. So these intersect at that coordinate, 5, 4, but let's put 5 and 4 into the other one to make sure. That's 10. minus 4 equals 6. We're moving on. Renee, let's go down the alleyway here. Got Renee the cart working overtime. There we go. 2/5. Got to make sure students have no trouble with fractions. And since it was fifths, I would hope you're taking a little bit of a shortcut and writing minus 35 over 5 at this stage, and seeing 6 minus 35 is minus 29 over 5. Right, because we're going to be doing 120 problems in 2 hours. Got to know your stuff. F of x, well, I know f of x is 3x minus 7, so we'll do 3x minus 7. I'll multiply it by 7. That gets me 21x minus 49. I can do the rest in my head. So I know I'm dividing by 21. That takes care of that. Add 49 to 3, you get 52. F of x equals 7x plus 4. Got to make sure I've got this camera on the proper height. Barely. Okay, there was a g of x here as well, but we're really doing f of x. And if you're a student and you have to take SATs or TOEFL or whatever, that means the same thing, f of x. Well, I know what f of x is. It's easier to see this notation right now because I know what f of x is. It's the calculation 7x plus 4. And I know I'm going to plug that into 7x plus 4. And if I do, I plug that as my gateway for my evaluations. 7x plus 4, and then I got to add 4. Well, that's 49x. 28 and 4 is 32. Let's go, Renee. All right. We're doing a lot of cube rooting now. And students are getting much better at that. 5x. And the factored form for this starts with the cube roots. 5x minus 2y. Everything after is built off of these two numbers. I have to square both of them. That's 25x squared. I have to square that. That's a positive 4y squared. And what goes in the middle? Some cancellation. Otherwise, I'm going to get 6 terms. And I want 4 of them to disappear. And the way to make that happen is to multiply minus 2y times 5x, which equals minus 10xy. And remember to change the sign. All right, what's the range of cosine 20 cosine 5x minus 3 plus 5? Well, remember what the cosine function does. It kicks out numbers between plus and minus 1. That part of the calculation, that's its only job. Kick out plus minus 1. I didn't know I was hiring this, but okay. So that's the center line. When you start to plot, you plot the center line first. You look at the amplitude. You go up by 20. You go down by 20. And what's my range? Y values that are less than or equal to 25. They never get bigger than that. In fact, one period is going to look like that. I pick the proper numbers, and I got to be bigger than or equal to negative 15. And I hope that if you see 120 problems like that in 120 minutes, you're just writing your answer down in 10 seconds or less and moving on. So 10 seconds are left for the average problem, 10 seconds. So what's that? 6. So 6 into 120. It should take you 20 minutes to do the test. All right, so can you see that this is going to have a center at 2, positive 6, negative 6. If I square these numbers, I get 4 plus 36, which is 40, plus 9 is 49. So therefore, just by looking at it, I can see the center is 2, negative 6, and the radius is 7. And I want you to be able to do it that quickly. And many of you can now. All right, so for those who are still practicing this, you know the drill. That's what I put down on my test, YKTD. You know the drill. I write this, you should immediately know you're looking at this circle. Okay, so what's 40, negative 40 on this side becomes positive 40 on that side. There you go, we moved it. This is a Pythagorean relationship. Right triangle, one side is x minus 2, the other is y plus 6, and the radius is 7. That's what's going on. The inverse of addition of 4, the subtraction of 4, and the inverse of e to the is ln of. Now, very easy to say this as well. It's very easy. The question is, how do you determine which one's right and which one's wrong? Plug in a number. E to the 1.1 plus 4 is approximately 7. Therefore, the ln of 7, therefore 1.1 gets a 7 on this side. 1.1 gets a 7 here. Then the inverse is 7 should get us 1.1. Well, which of these? I don't know the ln of 7. I got no idea what that is. Well, I got an idea, but I don't know how close it is. But I plug in 7 here. Oh yeah, ln of 3 gets me 1.1. I guess that's the correct inverse. And when I subtracted 4, that's a new number. And if I'm going to do something, some function on that new number, I better put it in parentheses. Very important Algebra 1 concept. Early algebra concept there. Could, digest it, check with a number quickly. All right, 3/5 x. And the only reason I put that on there was to really highlight inverses. The inverse of multiplication is division. The inverse of division is multiplication. Just on the real gut level. I want to make sure everybody has that thought. All right, so what would be friendly number here? 3. 3 would be friendly. Then the 3's cancel and you get 5. So over here, a 5 should be friendly. Oh yes, the 5's cancel and I get a 3. All right, let me shut the door here. All right, so what do we have? The vertex. All we want is the vertex. On this cup shape down, I want the x and the y. Well, the x comes from minus b over 2a. Minus b, minus 12 divided by minus 6 is 2. And that means I'm on the upside. 0 gets me negative 7. I know that. So 2 makes sense to me. 2 makes sense to me. All right, if I plug 2 in, I know I get 24 cut in half is 12 minus 7 is 5. And there's the vertex, 2, 5. You might have to plug 2 in and get negative 12 plus 24 minus 7 to get your y value, which is half of 24 minus 7, which is 5. There are patterns and shortcuts everywhere in mathematics, and when you see them, use them. Okay, vertex. Well, that means x plus 5 squared plus 7. That means this is acting like 0 squared, that x. That's the minimum of squaring. So it's got to act like a 0. How do I make minus 5 act like a 0? How do I make it act like a 0? By adding 5. So that's the geometry behind it. Okay, now what happens? I go from negative 5 to 1, but I'm squaring. That's just my change in x. But what am I doing to my change in x? I'm squaring it, which means I now have 36 units. Negative 5 to 1 is a change of x of 6. If I square it, it's 36 plus 7. And I know that takes me to 12. So that works. Oh, it doesn't work. I'm sorry, it doesn't work. I didn't realize that. Well, why don't we get rid of it? Why don't we get rid of what doesn't work? And figure out what plus 7 takes us to 12. Yeah, I think from 7 to 12 is 5 units of change, and that's my function, whose vertex is negative 5, 7, and also passes through 1, comma, 12. Do the math. Minus 2x squared equals 4, so x squared equals minus 2, and I am just trying to see how many people remember plus minus. Failure to do that is a half a point deduction. And how many people put the square root of 2 here, but if it's a negative, put the I at the end, and that's a half a point right there. And that's a half a point right there. And if you see one of those from me, You're happy, I'm happy. 3x squared equals 2x. Therefore, 3x squared minus 2x equals 0. There's the mechanics. And then therefore, x is common. 3x minus 2 equals 0. And I have x equals 0, comma, x equals 2/3. Now, from the standpoint of what you need in a calculus class, you'll find the area bounded by two curves. You need to know 2x is a linear function that's climbing and 3x squared is a parabola. And then you'd have to find those points of intersection and learn how to compute that area. Well, it's pretty hard to have the discussion about the area if you can't do this mechanics. And if you can't plug 0 back in to see that 0, 0, and 2/3 times 2 is 4/3. If you can't find those coordinates, then you can't integrate with respect to y, and you can't integrate with respect to x. Okay, just showing you what's coming down the road. 5i to the 23. I'm glad I just erased that. That was really smart of me. I do a lot of those things here. So this should be minus 5i. Okay, looking at it, when I looked at it, I saw I squared fits 11 times. Well, that's -1. And 22 to get 23 is I need one more I. So -5i. It all comes down to that. That exponent. When it's odd, I get one of those. When it's even, I don't. Squaring. I see 49 as a bookend. I see 16i squared as the other bookend. And both are positive when you square numbers. Doubling the product gets me minus 28. Doubled is minus 56i. And that I squared makes positive 16, negative 16. So 33 minus 56i. Okay, I don't think I've lost the camera yet. Let's go, Renee. We're on the Motor Speedway here. All right, so let's just square this one. 9a, 16b. Let's take that product and double it. That's minus 15, so minus 30. And I still have to multiply times a8, b, a7, right? If I multiply 2 times 5bc, if I double that, I get 10bc. The exponents don't change. Oh, wait a minute, I got an a here. I don't usually do that. So that's going to be a to the 15th. I gotta put that together, right? If I'm multiplying this, boy, I don't usually do that. A little curveball here. A to the 15th b, and squaring that gets me 25 a to the 14th. Righty? Yeah, boy, curveball. So I'm seeing 3 square root of 16 square root of 2 minus 2 square root of 4 square root of 2. So therefore I'm seeing 12 root 2 minus 4 root 2. And that's like saying 12x minus 4x. All right, let's let x equal root 2. So that's 8 root 2. I'm seeing fraction equal fraction. I'm going to do cross products. Why I wrote that, I don't know. I could certainly do it a different way and reduce that. But let's do cross products. That's what I wanted to make sure we talked about. So 2x squared has to equal minus 28x. So x squared has to equal minus 14x. So therefore x is 0 or x is, well, let's do the workout. In case somebody, so I'm going to add 14x to this side, set it to 0. And now I factor out x plus 14 equals 0. So therefore x equals 0 or x equals negative 14. All right, let's go, Renee. Let's get the roots. So the roots are, looking at it, x equals 2 plus or minus the square root of 11/3. How do we know that? Because if you put this in graphing form, you're going to get a rotator cuff problem. And let's move that. All right, so a 3x minus 2 squared. I probably have to adjust the camera, equals 0. No, you can see that. I mean, that's what we're doing. We're trying to, roots are when you hit a height of 0. Didn't have to be 0. If it was 1, if I wanted a height of 1, then I'm going up 12 units. Well, that's a nice one. That's factorable. Wow. Whew, I got a factoring problem. But I didn't say 1, I said 0, so it's 11. All right, I hope you can see. You'd add 11, you'd divide by 3. You do plus minus square root. And then you would move the -2 over. If I do that and I keep doing that, do I really have to write out the work? Or can I just tell you what the answer is? And if this is all about getting better at math, I think the things you see more easily and quickly, the sharper you are. I hope that's a true statement. I don't. So this was a repeat question on the last test. It was x to the 4th minus y to the 4th, and people did not factor it completely. So this is a retread. And so this one's going to be a little on the long side on your answer key. So we're not doing that one, but I'm trying to see if you learned from that one. And did you say x to the 4 plus y to the 4? Times x to the 4 minus y to the 4, which is x squared plus y squared, times x squared minus y squared, which is x plus y times x minus y. Now, x to the 4th times x squared is x to the 6th times x is x to the 7 times x is, oh my word, x to the 8. Could I check this with a number? Of course you could check it with a number. Am I gonna? No. So x squared plus x divided by 4, that means that's a 6. I bring it to the other side. I got a beautiful trinomial. I can look at that from the factoring context. A 3 and a 2, because I'm 1 apart, so the bigger number gets the positive, the negative, and I get roots, zeros, created when I pick -3 in a table, or if I pick +2. We can go back and check it 2 real quick. So that's 16, 2 times 4 is 8, and 16 plus 8 is 24. Doesn't hurt to check something like that quickly, especially if it's a final exam and you're looking to pick up the spares from Candlepin Bowling. Oh. So I got a 5A and an A, and whatever I pick is 3 times the size of what I think it is, and I want to get close to 17. So I'll pick a 3 and a 2. There's my 15 and 2, there's my 17, and they both are negative. Bingo, bango, bongo. So I'm not going to do bungo. I'm going to do z times z minus 2, just in case whatever I get up here has some cancellation. So I've got 2z minus 4 minus, remember, when I multiply that, I get a new number that has 2 parts. And if I'm subtracting that new number, I got to subtract both parts. And what parts do I have? I've got z squared in here, and I've got positive z in here. So that gets me 2z minus z, which is a z over here in the numerator, minus z squared. I'll put first, descending powers. That was a positive z. And I've got -4 minus, oh, that was a z, huh? Yep, so just -4, I guess. I feel like I'm too close to the board here. I hope I'm not making any mistakes. Z over z minus 2. Because I'm not sure if I'm making any mistakes, let's pick an x value that would be fun to work with. How about 1? Let's put 1 in. Then that becomes 2 over 1 minus 1 plus 1 is 2. 1 minus 2 is -1. I'm getting the answer 3. Oh, so let's put the number 1 in here and see if it comes out as a 3. And then I'll feel good finishing the video saying, oh, I didn't make another stupid error. All right, so I got -1 plus 1. I like that. -4. I don't like that. 1 times -1, -1. I don't like what I just did. So let's check my answer here. Always right at the end of the video. But this is math. I put in a 1. I got 2. 1 minus 2, -1. 1 plus 1, 2. Minus a -1 is going to be a positive. And 1 plus 1 is 2. And 2 plus 1 is 3. So I multiply 2z minus 4 minus z squared plus z. Z times z minus 2. 1 times -1 is -1. And 2 times 1 is 2 minus 4 is -2. Oh, 2 times 1 minus 4 is -2. Oh, I think I found it. But over here it was a 1, right? So that had to be a 1. -2. All right, so let's do that. Now I'm really too close to the board. I'm not gonna do this video again. I'm just gonna be more careful with this. All right, two Z minus four, that's right. I don't need to do that. This is Z squared, yes. Minus Z, that's correct, I'm seeing that. This is over Z squared minus two Z, we'll write it that way. Now, when I put in a one, well, first off, we gotta get this minus Z squared, two Z minus a minus is three Z. I think that might have been my mistake. Minus four, nothing, so just minus four over Z squared minus two Z. Now when I plug in a one, well, I get a three, so that's minus one. Three minus four is minus one. I don't like it again. One squared is one, minus two times one is minus two. And so that's minus two. All right, Yasser, come in and bail me out. All right, I'm in that stage where, yep, it used to be dark out when I got here. Now it's light. And always at the end of the video, the brain just shuts down on me. So you figure it out for me, Yasser, and chime in and stay safe and warm. All right, appreciate it if you do. All right, I got to get going. So I am under a little time pressure. Bye-bye.